Okay, we were talking about acids, and we had said that we figured out why water has a pH of 7 and is what we would call neutral. It's because water is the solvent for life, and it produces hydrogen ion concentrations of 1 in 10 million. Now, with a base, so I'm going to look for my definition. Bases, I'm going to show you this in our new high-tech approach. Bases are proton acceptors. They have a bitter taste and they feel slippery. And we have a couple of examples there, sodium hydroxide and potassium hydroxide. Now, if you remember, we had said water will go from H2O to H positive and OH negative. And we had said it can go out that way or back the other way. We drew arrows going both directions. And so what happens with a base is a proton acceptor. And we had said an example of that is a potassium hydroxide. And when we had said as a proton acceptor, they're going to make the hydrogen ion concentration smaller than that. And we said our scale is a logarithmic scale. It's a 10-fold scale. So if you have water, I'm going to quickly draw this up here. H2O, this direction or this direction, H plus OH negative. So we had said this thing, it can go this direction or it can go this direction. If you start adding more of this, on this side, you're going to remove these and push this thing back this direction. And so if you make it 10 times more rare, if you remove 10 times, a 10-fold amount of hydrogen ions by adding this to this side, it goes from 1 in 10 million molecules to 1 in 100 million molecules. That's pH of 8. And then if you keep adding this so that it's another 10-fold, that would be 100 times less. That would be pH 9. And then if you add more and more and more, and it's 1,000 times less concentrated than water, it would be a pH 10. I think that's where we are. But my point is, this is a scale. It's measuring hydrogen ions from 0 to 14. So the most basic, and that's some crazy rare number there. I don't even know what the number would equal to, but the whole point is it would be 1 times 10 to the negative 14, whatever that is. So they become more and more rare because you notice the base is not adding, we're not adding any of these, we're adding this. This doesn't count. It's pH is the measure of these and these only, the measure of this, hydrogen ions. So by adding OHs, we make the hydrogen ion concentration smaller until we have filled out the entire pH scale, which has pH 7 as neutral, 0 is pure acid, 14 is the highest number, the lowest concentration of hydrogen ions. That's the pH scale.